If our function is in the form y equals u divided by v, so something divided by something else, we can differentiate using the quotient rule. And the quotient rule says that dy dx is v times du dx minus u times dv dx all over v squared. So if we've got a function divided by a function, we're using the quotient rule, and it's v du dx minus u dv dx over v squared. So in our first question here, y equals x squared over 2x plus 3. So we can say that u is x squared. That's the one on the top. U is x squared. And v is 2x plus 3. So we differentiate them both. So du dx is 2x. And dv dx is 2. Now just substitute them in. So dy dx is v times du dx, which is 2x times 2x plus 3, minus u times dv dx, which is 2x squared, and that's all over v squared, which is 2x plus 3 squared. We can simplify this, so if we expand the bracket, we get 4x squared plus 6x. So 4x squared take away 2x squared is 2x squared. So we've got 2x squareds plus 6x's over 2x plus 3 squared. And we'll leave it like that. For part B, again, the top one is u. So u is 5x, which means du dx is 5. V is 3x minus 1 squared. So dv dx, so we times by the power, take 1 off the power, and then times by the bracket differentiated. So we're going to be timesing by 2. So it'll be 2 times 3x minus 1, but then times by 3, just to save space. I'm not going to write them both down. It's going to be 6 times 3x minus 1. So times by the power, take 1 off the power, times by the bracket differentiated. That's the chain rule. So dy dx is v times du dx, which is 5 times 3x minus 1 squared, minus u times dv dx, which is 30x times 3x minus 1, all over v squared. So 3x minus 1 squared times itself is 3x minus 1 to the power of 4. Then to simplify, we could divide through by 3x minus 1. So divide both the terms in the numerator and the denominator by 3x minus 1, which will leave us with 5 times 3x minus 1 minus 30x over 3x minus 1 cubed. And then again, we can expand and simplify the top line. So we're going to get 15x minus 5 minus 30x. So we've got minus 15x minus 5 over 3x minus 1 cubed. So we will leave our answer as that. Okay, 2 for you to try. See if you can give them a go. So they're both in the form y equals u over v. So we're using the quotient rule. So we need u, which is our numerator, x minus 2. And du dx is that differentiated, which is 1. V is 3x minus 1. That's the denominator. And dv dx is that differentiated, which is 3. So dy dx is v times du dx, which is 3x minus 1, minus u times dv dx, 3 times x minus 2, over v squared, which is 3x minus 1 squared. Expand and simplify the top line. So we've got 3x minus 3x. So 3x minus 1 minus 3x plus 6. So 3x minus 3x is nothing. Negative 1 plus 6 is 5. We've got 5 over 3x minus 1 squared. And part B, so u is 4x, du dx is 4, v is 3x minus 1 squared, dv dx is going to be 6 times 3x minus 1. Then dy dx, v du dx minus u dv dx over v squared. Divide through by 3x minus 1. And expand and simplify the top line. So we've got 12x take away 24x, which is negative 12x, minus 4 over 3x minus 1 cubed. And another set of questions. Again, we've got something in the form y equals u over v. So we're using the quotient rule. It's just that this time we've got logs and trig functions. So u is e to the power of 2x for the first one. So du dx is 2e 2x. V is cos squared x, which is the same as cos x squared. So dv dx, using the chain rule, is 2 cos x times the bracket differentiated, which is negative sine x. So it's negative 2 sine x cos x. Substitute them in. So dy dx is v du dx. So 2e 2x cos squared x minus u dv dx. So it's minus, so plus 2e 2x sine x cos x over v squared. So cos to the power of 4x. We could divide through by cos x this time. So we're going to have 2e 2x cos x plus 2e 2x sine x over cos cubed x. Then we could factorize out the 2e 2x, but I'll leave it as it is. Part B, u is log x. So du dx is 1 over x. V is 2x minus 1 squared. So dv dx times by the power, take 1 off the power, times the bracket differentiated, so times by 2, and then times by the bracket differentiated, which is 2 again. So it's going to be 4 times 2x minus 1. And then dy dx is v du dx, so 1 over x times 2x minus 1 squared, minus u dv dx, 4 log x times 2x minus 1 over v squared, which is 2x minus 1 to the power of 4. So we're going to want to divide through by 2x minus 1. So the powers go down by 1. And then let's get rid of the fraction by multiplying through by x. So we're going to have 2x minus 1 minus 4. So multiplying this term by x for x log x over x times 2x minus 1 cubed. And I'll leave it as that. Okay, 2 for you to try. See if you can give them a go. So if u is e to the power of x, du dx is e to the power of x. When we differentiate e, it stays the same. V is sine 3x. When we differentiate sine, it goes to cos, but we times by our bracket differentiated. So dv dx is 3 cos 3x. Then we just put them in. So dy dx is v du dx, ex sine 3x minus u times dv dx, 3e x cos 3x over v squared, so sine squared 3x. The second one, u is log 2x. Du dx is 1 over x. I'll quickly explain that. So u is log 2 plus log x using the rules of logs. So du dx, log 2 is just a constant. It's got no gradient. Du dx is 1 over x. So du dx is 1 over x. We could also say it's 1 over 2x times by the bracket differentiated, which is 2, and then it's just 1 over x. V is cos x. So dv dx, cos differentiates to give negative sign. So dy dx is v du dx, 1 over x times cos x, minus u dv dx. It's minus minus, so plus, and it's log 2x sine x over v squared, which is cos squared x. I'll multiply through by x, so it's cos x plus x log 2x sine x over x cos squared x.